Welcome to the today's LeetCode problem. So today's LeetCode problem is the count number of good subarrays, which is a medium level problem. Of course, what we have given? We have given an integer array nums and the integer k, and we have to return number of good subarray of nums. What is a good subarray? A subarray of array is good if there are at least k pairs of indices ij such that I is less than j and AR of I is equal to AR of j. Basically, we have to count the number of pairs in that subarray should be at least k, where both indices elements should be same. For example, if you are given the array like this 1, 2, 2, and we have been asked k equal to 1, there should be at least one pair. So number of good subarrays would be this completely 1, correct? This one, and I would say this one, correct? So there are of two subarrays having such case, correct? So we have to just return this count, that is number of 2. So if you see this test case 1, they have given, we have to count number of subarrays where at least there should be k equal to 10 pairs. So if you see, if I consider only this subarray, that is 4 ones, so see 1 has frequency 4. So there is one shortcut formula to count number of pairs, how it can do. So it should be frequency into frequency minus 1 divided by 2. So if you see, using the 4 frequency, how many pairs we can generate? 4 into 3 divided by 2, that is 2 into the 6. So no, it's not possible, right, to generate at least k pairs. So if you see, if I consider the whole array, that is 5, so 5 into 4 divided by 2, it will generate the 10. That's why we have to consider all like complete nums to in order to get a 10 pairs having all elements equal to same. So if you see, the output is a 1 for this case, correct? If there it would have been the case, instead of this 1 there have been the 2, then the output would have been the 0. Why? Because there is no subarray having at least 10 pairs, and in that pairs the pair element, whatever the element we are pairing with, are same, correct? Because that is what we have given, error of I should be equal to error of j. Let's now see the test case 2, this test case. So we should have at least 2 pairs. So if you see, if I consider this subarray, correct? So if you see, 3 has frequency 2, 1 has frequency 1, 4 has frequency 1. So of course this element can never pair because its frequency is 1. But if you see, 3 has frequency 2. So if you see, 2 into 1 by 2, that is 1. Only one pair we can generate, but we want 2 pairs. So if I increase the size of subarray from here, if I increase it from here to here, so if you can see, 3 has frequency 2, 2 has frequency 2. So if you see 3, 3, 2, 2, these are the 2 pairs that we can generate. So of course we can have the subarray using this contiguous subarray. Now how many subarray we can generate? This is a 1, this is a 2. So we can generate a 2 subarray using these elements. Now if you move forward, this is 1, 4, this is 1, 4. So 4 has also the frequency 2. So almost there are, if you complete the whole array, so there are 3 elements having more than, at least we have been asked, right? So but there are k equal to 3 basically. In this case we are getting the 3 pairs, right? So what we can do, we can shrink the array. How we can shrink it? See, if I want to just this, I got, how many pairs I got? Initially 2 pairs, right? 2 subarray, not a pairs I would say. So this was the one subarray, correct? This was the another subarray which is following the condition. If you see, this is the one subarray which is again following the condition, correct? And this is also the one subarray which is also following the condition. Because if you consider this one, so see there, 4 has frequency 2, 2 has frequency 2. So it means I can generate a pair like this, and this is what I have been asked. So if you count all of them, so 1, 2, 3, 4, that's how output is a 4 for it. And this is what the pairs, this is the subarray they have given here. So how we can solve this problem? So of course the constraint has been given 10⁵, so we have to solve it in big of n log n or big of n only. We can't go for big of n square. So whenever there has been asked something kind of the subarray, so first thing that should come in our mind is a sliding window, because sliding window is something that is giving will give you the idea how to solve this problem when we have the condition to shrink. Correct. When we have to shrink, first of all you have to understand why we have to use the window, and then second, if we are using the window, sliding window, then we should know when we need to shrink it. Correct. So why we have to use sliding window? Because we have been asked for subarray. Sliding window will help you to count the particular condition based subarray. That is a good subarray here, given here. Second, when we have to shrink. So if you observe completely what we have been asked, we have been asked at least k only. So whenever I am getting at least k, what I will do? I will shrink it. So when I get at least k pairs, shrink it. That's it. Because I never want ki I should get the subarray having pairs more than k. So I will always shrink it. And whenever I am shrinking, how many pairs are possible? For example, this is my subarray given to me, 1, 2, 2, 3. Correct. So if you see, till here only I am getting the good subarray, because suppose I have given k equal to 1, only one pair I want. So using this subarray, how many subarray I can create with the remaining elements? So if you see, the length is 4, the index is 0, 1, 2, 3. So 2, right? 4 minus 2, that is a 2. It means that using this subarray, you can generate total 2 subarrays. How 2 subarrays? This can be the 1, of course, 1, 2, 2. And then this can be 1, 1, 2, 2, 3. Remaining elements basically. So after 1, 2, 2, whatever the number of elements are there, just subtract it till here. Because these are the elements will give you number of subarrays. So if there are 4 elements, so you can generate 5. Because considering this one as well, if there are 5 elements, then you can generate 6, because this 5 plus this one 6. How? This can be the one subarray, 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 this can be the one subarray. And whenever I am getting this situation, what I am doing? I am shrinking it. How I am shrinking it? By just moving from here to here. So now I shrink it. Still I can get a good subarray. So I will count this one, this one, this one, this one, this one again. So this is how I can solve this problem easily. Now let's understand this scenario with the help of test case. So I will just take the sample test case, whatever we have given, 3, 1, 4, 3, 2, 2, 4. I will just take it here. 3, 1, 4, 3, 2, 2, 4. 3, 2, 2, 4. And we have given k equal to 2. Correct? Now I will try to use sliding window approach over here, where the standard approach is that use the left and right pointer. So initially my right will be here and my left also will be here at start. Correct? Then I want to count number of pairs. So for counting the number of pairs, I need to have the frequency hash map, something like that, which will tell me the frequency of any element. If you observe, if in my array this is 2, and if I have been asked k equal to 1, so whenever I am getting here, I will just say, hey, what is the frequency of 3 I have seen so far? I have seen so far as 1. So I know that this 3 is going to pair up with this 1 frequency. That is how many pairs I will get? 1. If I would have been 3, 3, 3, right? Till here, I would have got the pairs equal to 1. When I am going here, I will again ask, hey, what is the frequency of 3 I have seen so far? That is a 2. So this 3 is gonna pair up with this one and this one. So that is pairs equal to now this initial one plus 2, because current frequency seen so far. So at every step, I am gonna pair up with a previously occurrence of that element. So I need to know what is the frequency of that element I have seen so far. So this is 3 pairs I will generate. And of course, this can be the one, this can be the one, correct? 2 pairs, these are the 2 pairs. And this also can be the pair. So this is how I can generate the 3 pairs. So that's why I need a frequency hash map over there, which will tell me what is the frequency I have seen so far for this element, so that I can increment my total pair count. So what I will do, I will maintain one pairs count element, correct? That will be initially 0. And whenever I am reaching the pairs equal to 2, greater than equal to 2, I will just shrink my window. This is what our condition, because in sliding window we have to shrink it. Then only we can proceed to count another remaining good subarrays. So initially I am here, what is the frequency? So I will just ask, hey, what is the frequency I have seen so far for 3? So initially it will be 0. So I will just say 0 plus 0 would be 0. Makes sense. And I will just check, is the pair count first step would be check frequency, previous frequency I would say. Then what you have to do, once you check the previous frequency, then pairs would be pairs plus frequency of that element seen so far. Then what I will do, I will update the frequency of that element. How will I update? I will update just +1. Correct. This is my second step. Third step would be, if pairs are greater than equal to k, then shrink it. This is our condition. This is our condition. How we will shrink it, we will see it here. So now I am here. Correct. Now I will move my right pointer to here. What is the frequency of 1 I have seen so far? So frequency of 1 I have seen so far is 0. Again 0. So now again my pairs will become 0 plus 0, that is a 0. Again this condition is not getting true. I will just update the frequency of this element, that is from this 3 I have 1, this one now. Now I will move my right pointer to here. Correct. Now I will again check what is the frequency of 4 I have seen so far. So till now I have seen the frequency at 0. Correct. Still now my pairs will become now again 0. Correct. Again I will check, I will update the frequency of this element, that is from 0 it will now become 1. Makes sense. Now I will again move my right pointer from here to here. Correct. Now I will check the, what is the first step? Check the frequency and pairs plus frequency of that element. So if you see, frequency of 1 is 3, frequency of 3 is 1. So now my pairs will be 1. Correct. And I will just update the frequency of element by 1. So this will become now 2. Now I will check if my pairs count is greater than equal to k. No, still I have only one pair, but I need 2 pair at least. Makes sense. So I will move ahead. So I will move ahead. Again, I haven't seen so far 2, so I will just update because previous frequency of 2 was 0. Makes sense. I will just update the pairs equal to frequency of that element, that is 1 plus 0 is ultimately the 1, and I will just update the frequency of that element, that is going to be the 1 now. Correct. Now I will move my right pointer again to the next. So now my right pointer is here. Correct. Let me give the indices over here, that is 0, 1, 2, 3, 4, 5, 6 and length is 7. 0 based indexing. So yeah, length is 7. Now I will check, I am here. What is the pair? Check the frequency. What is the frequency of that 2? Already 1. So pair plus frequency of that element, that is 1 plus 1, that is a 2 now. Now I have got pairs equal to 2. If pair is less than equal to, greater than equal to k, that is 2. Correct. True. Then shrink it. How we will shrink it? First of all, before shrinking, we have to count the number of good subarrays, because I have got something k pairs now. So how many pairs, how many good subarray I can generate? First of all, this would be the 1. Correct. This would be the 1. This would be the second. That is length minus right pointer index. So good subarray would be nothing but length minus right index. Length is 7. Right index is, right is here at 5th. Correct. So 7 minus 5, that will be the 2. So good subarrays will be 2 now. I can generate 2 subarrays so far. So I will shrink it. How I will shrink it? I will just move my left pointer to the next. So before moving it, I will just decrement the frequency of this element. What is the frequency of this element? 3. So I will decrement it. So now it will become 1 by 1. And I will update my pairs count, because as the frequency has been decreases, my pairs count will be difference. Okay. Subtract the frequency of that element. That left. What is the frequency? 1. So my pairs will become now 1. Why? Because I don't have 3, 3, right? Because there is only 1 3 present, because now my left pointer is here. Correct. So this 3 has been vanished. So there is no 3 again present, so that's why this will become 1 now. Makes sense, right? Now what I will do, again I will check, is my pair count greater than equal to k? No, it is not, because it is 1. So I will move my right pointer here. Now I will check, what is the previous frequency of 4? That is a 1. So I will just say pairs equal to frequency of that element, that is 1 plus 1, that is a 2, again 2. Now I will increment the frequency of that element, that will become 2 now here. Correct. And this would have been again 2, of course. So I forgot to update it. So now I will shrink my window. before shrinking I will count the sub array. So where I am, correct, I am at here, so that is 6. So 7 minus 6, that is gonna be 7 minus 6, that gonna be 1. So good sub array, this was 2, this was 1, correct, incrementing it. So I will now shrink it. So I will move my left pointer from here to here. When I am moving, I will decrement the frequency of this, that will become 0, and I will just subtract that frequency from pairs. So 2 minus 0, which is ultimately 2, because this is not gonna be part of the pairs, of course. So makes sense. Now I will again check. Okay, I will say I am here, right? So again I will say good sub count will be length minus right, that is again 7 minus 6, which is ultimately 1. So 2 plus 1 plus 1, that is going to be 4 for this. Why? Because whenever I am moving from left pointer from here to this 4, right here, now I am decrementing the frequency of 4, that is going to be, what you say, 1. And whenever I am reaching at 1, I can see now I don't have the pairs, because pair count is going to be now 1 only, because I am updating the pair count. And I will subtract this frequency from here. So 2 minus 1, which is ultimately giving me 1. So I will not have, again I will not have the pairs which is greater than or equal to 2. So which will not be the case. I will be done. So I will move my right pointer. So I will vanish with the length, and I am done with the sliding window. So if you see, this might be a bit confusing, but if you see the code is very simple. This is big of n solution. What I am doing, I have just taken the pair count, I have taken the left right index pointers, I have taken the n length of the array. Good sub array will give me the length number of good sub arrays, and this is my frequency. I am using the default dict, so I don't have to check whether the key is present in or not in hash map. What I am doing, this is the standard way of writing it of sliding window. While my right pointer is less than index, what I am doing, I am just incrementing the pairs count with the previously seen frequency of the nums of right. So if I am here, correct, I am here, so how many pairs I can generate? 3 as a frequency 1 when I am here, correct. So pairs would be this plus 1. So I am just doing that one. So I can generate a 1 pair now, and then I am updating the frequency by 1. So now my frequency will become a 2. So when I am reaching to the next 3, so I will just say pairs, this was plus 1. Next step I will just say pairs plus 2, correct, 2 frequency. So ultimately plus 1 plus 2, that is a 3. And using the 3 elements you can generate a 3 pairs. How? So we just discovered this formula, right? So 3 into 2 by 2, which is a 3. So 3 pairs you can generate, and this is what I am doing here. Now shrinking logic is that whenever I am getting pairs equal to greater than equal to k, what I will do, first my case would be count the number of good sub arrays. So what will it will be length, that is n is the length, if you see here, length of array minus right index, that is our case. Then I am decrementing the frequency of left index element minus 1. Then I am removing it from pairs as well. See, any element can be the part of pair when it has frequency that greater than 1. So for example, if my left is at 7 and 7 has frequency only 1, so ultimately this is not a part of pair. So when I am decrementing, though it will become 0. So whatever the pair count I have, x for example, x minus 0, there will not be any effect. But if 7 has a frequency somewhere around 4 for example, so ultimately we know that 7 is a part of the pairs. So when I am decrementing its frequency, that is becoming 3. So I will just say x minus 3, which will give me basically the new pair count. Why? Because using the 4 count, how many pairs I can generate? Sorry, 2, that is a 6, correct. So from 6, if I have frequency 4, but now I have frequency only 3, so I can generate only 3 pairs, correct. So I have to just decrement whatever the count I am missing, that is 6 minus 3, that will be 3, because now I can generate only 3 pairs using that. And that is what I am doing here. I am incrementing the left plus 1, and at every step I am moving my right to the right side, and finally I am returning the good sub array count. So this is a big of n solution. And of course the space complexity will also big of n, because we are using here the frequency hash map. So I hope you got this solution. See you in the next video. Thank you.